Okay, hello everybody. So this is Pires from Cisco Networking Academy. Today I'm going to present Module 8, Network Layer for the CCNA Module 1. Okay, let's start. So this uh, chapter is actually about network layer, and it takes some information about IP version 4 and IP version 6, and how also the host routes and also routing tables. So let's start. Network layer is the third layer on the OSI model, and it provides services to allow end devices to exchange data. So, and also it is mainly two versions of like native communication protocol, which is IP version 4 and IP version 6. So the principal operation of this network layer actually is four basic operation as being listed below, which is addressing the end devices. So all end devices need an IP address to be able to communicate with each other. And then the encapsulation, which it adds all the information needed in order to conduct this communication between networks. Routing also, it routes the packets among different networks until it reaches to the final destination. The de-encapsulation also it just examine, it sees the IP address to be able to identify to which network this uh, IP address or this data need to be headed, need to be routed. So you can see here, this is the IP encapsulation. When the data come above from the transport layer, which is the fourth OSI model, number 4. So it comes then this data as a whole, then it will be encapsulated in the network layer. This is the process of encapsulation, which it adds an IP header. It contains all the information needed for the communication. So IP packet will examined by the layer 3 device and it travels to the network because it needs to see to see the IP address and to know in which destination this should be forwarded. And the IP address does not change from source to destination. This is the case with IP addresses, but there is one of the notifications that it uses sometimes the NAT protocol. This change the address in order just to make use of the IP address because of the uh, to maximize the use of the IP address. This will be discussed later. But generally, IP address does not change from source to destination. So the characteristic of Internet protocol of this IP, it says it's connectionless, it has best effort, and media independent. We will see each of one what it means. So IP connectionless, it means it does not establish a connection with the destination before sending the packet. It's like sending a letter. So when they leave the post office, when they send a letter to a home, they don't usually make sure that the home owner is available or not. They just put it there, and this is their work. For this level, for this layer, this is the work of the IP address or internet protocol. So there is no control information needed. There is no any synchronization, no acknowledgement. It means here there is no any acknowledgement or confirmation to say yes, I got the mail, or no, I haven't got the mail, or the mail has some problem. There is no anything needed here. And the destination will receive the packet when it arrives, but no further notifications are sent. As we have said, no notification will be sent. So, but when we want to make sure that this letter has been arrived, so the upper layer, which is the transport layer, is actually have this responsibility to track the data and to make sure that the data has been arrived or by using different protocols. This is the protocol used in the transport layer. The TCP protocol has this option that it has an acknowledgement, and also there is a synchronization, and there is actually a session connection between the sender and the receiver. But here in the network layer, this is not the job for the network layer with the IP connection. That's why they said connection. Best effort actually it makes all the things that it needs to be possible to send the packet from the source of the destination. Everything required regarding the IP, the addressing, the routing, all things they are ready to be sent, but they don't have the guarantee actually for delivery, as we have said. So this guarantee, this like ensuring of receiving the data, it is the job of the upper layers. Maybe some data will be lost during the transmission process, and this will be solved actually by the upper layer in the next maybe chapter. Then you will have the information about how we can then resend the lost data. Here it says media independent. It means so IP is unreliable, as we have said that because there is no any guarantee to make sure that the packet has been received. And media independent, it means different media can be used. So they in the part of the transmission there is a copper, Ethernet, copper serial, optical, wireless, different kinds of media could exist actually during the process of sending. But this is normal. It is media independent. So actually, this it says as long as the process of sending it starts, then the network will establish this maximum transmission unit. It will send the packet then immediately. Another thing here is the fragmentation. So this is done also when layer 3 splits the IP4 packet into smaller units. So it means when you make the packet into the smaller pieces, this is the process of fragmentation. But it causes actually delay. I need to check the activity. So IP version 4, they do fragmentation. IP version 6 does not fragment packets, so therefore IP version 6 is much faster than IP version 4. Okay. Here we have IP version 4 packets. So the IP version 4 is the primary communication protocol for network layer. Network layer, they use IP addresses in order to communicate. As we have said before, that in the layer 2, they use the MAC address for communication by. But here, the communication scheme in this layer is IP version 4. So the network header has many purposes. Actually, the header which is added by the layer 3, which it contains all the information needed to make this communication done. So it ensures the packet is sent to the correct direction. So correct direction, it means all the packets they have been managed correctly to the specific destination that you want to send it. It contains information for network layer processing in various fields. There is too many fields that is available in the header. It helps how to manage the packet to be able to receive to the destination. Also, the information in the header is used by all layer 3 devices that handle the packet. All the layer 3 devices, they can use this header in order to manage the communication between all devices. So here we can see the header. It contains different fields with different size of the bytes. So the main important thing here is the source IP address and destination IP address. Also, this TTL time flip, it prevents, when it comes to 0, it prevents the packet to have an infinite loop cycling inside the network. And it has so many other information that make possible for the packet to be delivered to the destination. So there is different kinds of the functions in the IP header flow. So as we have said before, TTL, this will discard the packet when it becomes 0. This is the counting process for eliminating the maybe there is a possibility that the packet still around making like when they don't have any destination because of some error that may happen. So the packet sometimes will still have a kind of input. So this will prevent this situation to be happen if the packet doesn't arrive to any destination. This will be dropped. Different kind of protocol could be used. Source IP address and destination IP address. This is the main thing that should be available in order to the process of communication. So there is a lot of videos that clarify and show the things how it works. So you can just simply review it by your account when you open the Cisco platform. We have your IP version 6 packet. There is too many reasons for improving the IP address from version 4 to version 6 because actually there is some kind of limitations for IP version 4. So IP version 4 has 3 major limitations. One of the most important things is the IP address depletion. So we have basically run out of IP address. It means any IP address it can be زور because the internet user number they are like increasing, and this limited number they are not enough anymore. So there are not an IP addresses. We are in the era of internet of things, internet of everything. So many things need to be connected. So the devices need connected. It needs usually IP addresses. So this is the major reason, the main reason for behind improving the IP version 4 to version 6. But also version 6, they have added so many other options to make better packet handling. And also lack the end-to-end connectivity. It uses this NAT protocol because there is no many IP address available, so they use NAT actually in order to make a change between the private IP address and public IP address in order to have as many IP address available to make sure that everything could be connected and everyone could have an IP address. So the IP version 6 actually solved the problem of the limitation of the number. Now the number is very, very huge. You see here this is 10 to the power of 36. This is something like enormous. So they increased the address space based on 128 addresses. So not 32. In IP version 4, they were it has 32 bits. Now IP version 6 it has 128, which is a large number. And also they improved packet handling. It's very simplified header and eliminate the need for NAT. There is no need for using NAT because NAT simply was used in order to have some more availability of the IP addresses, and they make it different kind, private and public. But now in the IP version 6, they all public. They have like a very huge number of IP addresses that's available for everything globally. So here is the header of the IP version 6. Some things has been changed. but not the source and IP address. The source and destination, they should be available in both. But there is some changes like regarding some IP version 4.12 were removed, like flood, fragment, offset, header checksum. Then some of them have been changed. Maybe they add the next header, payload length, some changes actually for better handling. So as you can see here, different functions with different descriptions for IP version 6, with the idea generally as is the same. They both are kind of address. So IP version 6 bucket header also it has a lot of information. So it provides optional network level information. Sometimes you can add a layer for the information, but they are optional. You can use it or not. And also, unlike IP version 4, routers do not fragment IP version 6. Fragmentation is done in IP version 4, but not in IP version 6. Also, there is different kind of videos, very helpful. The video you can review them. It's highly recommended. We can see here how a host runs. This is also very important subject to just have an idea behind the host and how they can get to send and receive between networks. So packets are always created at the source. Yes, the source creates the packet, and each host device creates their own routing table. They have own routing table in order to send based on that. A host can send packets to the following. So they can send packets to the following addresses. The first one is itself. If the computer wants to send something for itself, this is just done in order for like checking purposes, just to check the TCP IP that has been installed on this computer successfully. So you just think with this IP address, and if you have a successful reply, it means that this computer is working probably. There is no any problem with this. So أعطيها شيء استخدام كيف الكمبيوتر أكو مثلا command prompt and then print ping this IP address. What is the reasons to check visually take مثلا sending for itself just so that it gets to a computer address to shoot the change regarding the TCP IP protocol that has been installed successfully in this. And also the second one is the local host. The destination is the same on the same LAN. So this computer can send packet to the host within the same network. This is the same network to computer. So they can simply just send this communication between two computers within the same network. This is very easy. And also finally, this is the remote host when the device are not on the same LAN. When we have a device in another LAN, and there is a router between, so it means this is different LAN. Then also they can send to the device outside the LAN, but then it needs you need to have the default gateway IP address in order to do this process. So the source device determines whether the destination is local or remote. Yeah, it depends on the IP address. And methods of determination. So source chooses its own IP address and subnet mask along with the destination IP address. This is really important. So each IP address has subnet mask. So be able to identify this IP address. So and also the IP version 6. The same way the source uses the address and the prefix address by the local router to do this computation. So there is local traffic Okay, and we have also remote traffic. This is the local traffic. This is the remote traffic. Remote, it means يعني your DRAM. Remote يعني it's not belong to the same network. So as we have said, that default gateway is needed when you want to send a packet to the device remotely located. So a router or layer 3 switch can be a default gateway actually. يعني نفترض router habitant, it means the router will do this operation to route your packet to the different computer which is not in the same LAN. يعني يقول له أنا كودي different يقول له أنا كودي different router لازم. And this switch هنا إذا switch for local delivery. But router it will help to like send, to resend, or to convey your message outside your LAN. Feature for the default gateway, it must have an IP address in the same range as the rest of the LAN. مثلا same range. مثلا ده مثلا 0 أبقى network. 0 is this network. So this is 10 or 12, 15. So this may be 1 or 2 within the same range. So this IP address of the router, which should be 192.168.10.1. This is 192.168.10.15. Means the same range. Only the last byte, this would be changed. This should be changed. No any other thing, because this is the host portion and this is the network portion. The network portion should be the same always. So this would be the IP default gateway for this computer and for this computer. So it can accept data from LAN and it's capable for forwarding traffic off of the LAN. So it means router they should packet data off LAN to another LAN to computer غير دولتي to غير بلدي إذا router they should. It can route to other networks. This is the idea behind it. If a device has no default gateway or a bad default gateway, its traffic will not be able to leave the LAN. إذا كانت default gateway فلا دخول كده تبتدي مش أصلا دخلنا كده. No, the communication not is only inside the LAN security because there can be network not that communication channel. Yes, as we have said that gateway, default gateway, it could be either statically or through the HTTP in IP version 4. Then I check it in. So you can use static protocol أو حسب مثلا DHCP protocol هذا server هاخده بتاع IP version. The same thing also with IP version 6. Default gateway is a static route which will be last resort route in the routing table. All devices on the LAN will need the default gateway of the router with the intention traffic. So it says that identity of it to packet tracker remotely network جهة you have to include the IP default gateway on the IP default gateway. This is the case behind the default gateway. And there is the command which is netstack/r to examine the IP version 4 route table. We can see the IP routing table. We can just type this in the computer to see this table. Let's go to introduction to routing. This is also very, very important subject in this whole module. So router packet forwarding is really important. It has a lot of information and it explains actually in a very detailed way. And I will also explain to you by public pressure to make it more clear for you. So we have directly connected sometimes. So this router, for example, they are directly connected to this router. This PC is directly connected to this router. We have the remote. So for example, this laptop is maybe remote to this router or directly connected to this router. So you need to know this definitions. And the default route actually it's needed in order to forward all traffic to a specific direction. So we need to consider the default route if we have a remote network. We have two different kinds of the routing. We have static route, we have dynamic route. So static route, you have to manage this uh, statically. لازم تكتب المشي بشكل. or dynamic route يعني تيجي اوتوماتيكالي بالاوتبوت بشكل. يعني المفروض تكتب الكاش بتاعك حاجات. فهذا choice هذا choice they could do they could do continuation with the correct. So either statically or dynamically, and each one of them they have its own characteristic, and each it depends also sometimes on the security purposes that you need to make it static or dynamic. This is up to the network manager. There is some kind of the videos that shows exactly how this works. So this is finally the practice and the quizzes. So let me now show an example with public question. See how this works. So I just prepared this static pressure with routers. You see here. So the main thing is now the number of networks that we have. We have three networks. This is one network. This is two. This is three. So each line connects to a router with a network. This is considered as a network. Also, we have this one link. This is another network. This is one link. This is another network. Okay. So you can just count the number of networks because it's really important to be able to manage your network successfully. So, for example, if this computer, let me see, needs to communicate with this computer, this local, the same network. So this is simple. Go to this group, and maybe you can see IP config. This is the IP address. This is the subnet mask. If you want to send traffic to this computer, this is 113. Okay, we will send to 13. So simply just write ping 112.168.1.3, and here we are. We have this reply that's successful communication between those. The thing is, if you want to send packet to this computer, this is remotely connected. Okay, let's try. This IP address is 23.192.168.2.3. Okay. So we will send to the computer 3. We see that it is not able actually to deliver this packet to that. So the very first thing that you need to think about is to make sure that do you have that default gateway, because as we have said, if you have the default gateway, then you can send to the outside benefit. If you don't have it, then you cannot. So here we have the IP address, version 4. subnet mask. Default gateway, actually, we don't have it. Default gateway is not available, so for this reason, the connection will be failed. Now we want to add the default gateway. So from where you will get the default gateway? Where is the default gateway? The default gateway usually the IP address of this port of the router. So you need to see this IP address for this port of the router. You can do that simply if you like in your reality. So you can double click here, but I just make this because in the reality when you have a router, you need to like bring a laptop and special cable, which is called console cable. This kind of console cable has two different connection ports, RS232 to the console. So you can use this tool and go to the terminal. Here you can be inside the router. So we need to see this router enable. So the very useful command here is to type this show IP interface brief. It will give you all the ports that's connected. So we have gigabit Ethernet 000, which is connected to this network. 192.168.1.100. Okay. So this is the network portion. This is the host portion. So as we have said that the default gateway of the router, which belongs to this network, it should be within the same range. So the same range. This is 192.168.1. Also, this is 192.168.1 and 192. So it means all the IP addresses in this network, they should start with 192.168.1, and then you can type 1, then 2, 3, 4. So the first three numbers should be the same. The first three numbers in each IP address within the one network should be the same, and the last number then will be the range. You can do it from 1 to 254. So this actually, as we have seen here, check it again. This is the IP address which is belong to this network. Also the same range, the same three first number or the same with that network. And here is you can just put a number, different number from the range 1 to 2, 2, 5, 4. Okay, so this is the IP default gateway. This is the IP default gateway that you need to write it down in all computers. This network. So I'm just going to do it. Go to the IP configuration, which is the IP address. This is the subnet mask. So I will just write down the default gateway. This is the default gateway. So this is the IP address of this port of the router. Default gateway is the IP address of the port of the router that's connected to this. Again, press OK. Then you can check it again. See IP config. Now it says that yes, you have the default gateway. So I will resend again the same IP address. See now. Okay, now it's successful. See now the connection is successful with a computer which is located remotely, far away in the network. Then نظرة IP default gateway داخل برهنده شان هنا في computer عادي. But we can still do the communication with this computer even if you haven't enter the default gateway, because default gateway is only needed when you want to make the communication outside the network, outside here or here. So then another important thing that you need to do actually when you have two routers and a remote network, because routers by default they just can see the connected network. So this router, how many networks is connected to this router? Two networks, this network and this network. Okay, and what about this network? Maybe they don't know it. They have no idea. You have to add it. So let's see how also this works. There is another command which says show IP route. So show IP route is C, it means connected. This has to connect device any computer. It is the network as a whole. يعني يبقى في نتورك يعني كده رقم 8 يعني كمبيوتر رقم 8 كده رقم 2 يعني كمبيوتر رقم 2 بس كده 0 دي for all computers this network have the same number. So there is only two connected network, and this is the static S. This is what I have added to it in order to make this connection. So the process of adding this actually I can explain to you, but this is belongs to the chapter 10. So when it comes to chapter 10, maybe after 2-3 days, I will explain this in a detail how you can add a static IP address in order to make this connection with the remote network. So you can see here, and you can sometimes you can remove it. So if I remove this, so this is the first network, this is the second network, 2-0, this is 1-0, and this is the third network, 3-0. So this C, it means connected, directly connected. This is the network 3, this is network 1, this is network 2, as it was just stated here. So here we have added network 2 to this router because network 3 and network 1, they are directly connected to the port, but only we don't have information of this. So this has been added, this network 2 has been added. That's why it says it's static. It means statically has been added to this router. It could be sometimes you can remove it also. Okay, you can remove it, but let's do this operation in the coming chapters because I think this is all the information that is needed for this chapter. Another information that will be coming in the next chapter very, very soon. Okay, so I think that's all the main information. If you have any questions, then you can just simply text us by this group of people and instructors. Thank you so much for your attention, and I wish you good luck and all the best.